Hey there, activity series people. Here we have an activity series, the one that you guys have looked at and have on the back page of your packet, and it's shown here to the right. And then I have the first three examples that are on the homework page I had given you. And we talked about these, but it doesn't hurt to hear a little bit more discussion on this. So in each case on these things, we have a single compound by itself, be it sodium, copper, or iron. And the big question is this single thing going to replace what I've dotted in blue? So we're wondering if this is going to replace the metal. And in each case, one metal has the possibility of replacing the other. And I say possibility because the only way we can tell if a reaction happens and if a replacement does happen is if one metal is above the other in the activity series. And so we have to make decisions according to this activity series. You don't have to memorize the activity series over here. You have to, be able to interpret it when you see it. And so let's take a look. Let's say first off, we're going to look at, sodium and copper. So let's find sodium. Sodium's here, and copper, where's our copper? Copper's down here. So sodium is higher on the activity series than copper is. Since sodium's higher than copper, that means a reaction does happen. And so now we're going to have some compound of sodium and oxygen plus copper by itself. Well, to put sodium with copper, I have to worry about what's the charge of sodium. Because sodium has a predictable charge. And sodium is a positive 1 and oxygen's a negative 2. They both go into 2 evenly, and I get Na2O. Now I've completed this complete reaction by writing a single displacement reaction. I did write this one completely out, and the reason I did was because sodium, which was by itself, was higher than copper on the activity series. We look at the next two, and I could look at copper, which again we look at here, and magnesium. Now copper is lower, not higher than magnesium on the activity series. And so that means that in this case, although we could write a reaction, and that would be an excellent thing to do, it wouldn't be correct. There's no reaction. There's no reaction because, copper is not more reactive than magnesium. It's less reactive. So there's no reaction in this case. Let's look at the third of which. And we find iron on the activity series, and we find silver on the activity series. So, all right, iron is higher than silver. So we do have a reaction. And so we're going to put iron with the nitrate, and the silver is going to be by itself. And so I'm going to end up saying something plus Ag by itself. Now, putting iron with nitrate, we have no way of telling what iron is. And the reason is because iron is in the middle of the periodic table. And so we don't know what its charge is. You see, up here on number 1 with sodium, we could know what the charge was, and that was because sodium is part of group 1, and it's predictable. On the other hand, iron is in the middle and is a transition element on the periodic table. And for that reason, we don't know its charge, and we're just going to put it with nitrate as FeNO3. And we end up with a single displacement reaction like so. Activity series, gotta love it.